All right, let's get right into it. Today, we're going deep, really deep, right down to the very center of our planet. We're going to tackle a question that's equal parts fascinating and, let's be honest, kind of terrifying. What if the heart of our world just stopped?
You've seen the disaster movies, I'm sure. You know the ones. Total chaos, the world is ending, the whole 9 yards. But beyond all the Hollywood special effects, what would really happen? What's the actual science behind it all? That's exactly what we're going to dig into.
So why are we even talking about this now? Well, this whole thing blew up recently because of some headlines that honestly sounded like they were ripped straight from a disaster movie script. Let's take a look at what got everybody so riled up.
Suddenly, you're seeing it everywhere. Headlines screaming that the Earth's inner core has just stopped spinning. And this wasn't just some random blog post. It was based on actual scientific studies. What a claim, right? It definitely got people talking. But is that what's really going on?
Okay, so as you probably figured, the reality is, well, it's a bit more complicated, and thankfully, a lot less apocalyptic. And you know what? The real science is actually way cooler than the scary headline. So let's break down what's actually happening thousands of miles beneath our feet.
This is where we really separate fact from fiction. On one hand, you've got the headline, Earth's core stops spinning. Sounds like game over, right? But then you look at the science. It's not a total stop. The inner core's rotation just paused relative to us on the surface. Turns out this is part of a totally normal 70-year cycle of speeding up and slowing down. And the most important part? The whole core is absolutely still spinning right along with the rest of the planet once every day. No catastrophic halt here.
The key concept here, the thing that explains everything, is called differential rotation. Sounds fancy, but all it means is that the solid inner core and the rest of the planet don't spin at the exact same speed. The core has this little bit of extra spin, and that's the part that's slowed down, not the whole shebang.
So, how does this affect you and me up here on the surface? The answer is, it basically doesn't. We are talking about a change to the length of a day that is so tiny, so incredibly small, we have to measure it in milliseconds. And that's over decades. So yeah, definitely no need to worry about resetting your watch.
All right, so if the inner core's wobble isn't the big story, what is? Well, this brings us to the real star of the show. The inner core might get all the media attention, but it's the liquid outer core that's the true engine of our planet. It's the part that is, and I mean this literally, absolutely essential for all life on Earth.
And how does it do its job? Through a process with a pretty cool name, the geodynamo effect. Just picture it. All that swirling, molten iron in the outer core is basically acting like a gigantic, planet-sized electromagnet. It's a natural generator creating the massive magnetic field that shields all of us.
So how does this geodynamo actually work? It's like a four-step cosmic recipe. First, you've got heat from the very center of the Earth, which gets the liquid outer core churning. Think of it like a pot of boiling water. Second, the Earth's own rotation wrangles those churning currents into powerful, organized flows. Third, all that moving molten iron, that generates massive electrical currents. And finally, step 4, those currents create our planet's magnetic field. It's an elegant process and, yeah, completely essential.
Okay, so now we can get to the real hypothetical, the big one. Forget about the inner core's little pause. What if the outer core, the real engine, what if that stopped churning? What if the geodynamo just failed? Now we are officially in disaster movie territory.
You see, that magnetic field creates this incredible invisible force field around our planet. It's called the magnetosphere, and it's our planet's personal bodyguard, its first and best defense against a constant deadly barrage of radiation hurtling towards us from the sun, what we call the solar wind.
And if that shield went down, well, the collapse wouldn't be instantaneous, like flipping a switch. It would be a slow, creeping disaster. In the first 1,000 years or so, our technology would be toast. After that, as the field keeps decaying, the radiation levels on the surface would climb. And then, over millions of years, the solar wind would just scour our atmosphere away into space.
So let's paint a picture. What would life actually be like on a planet without its shield? The consequences would ripple through everything, from our tech right down to the ecosystem itself.
First up, all the technology we rely on, it would just crumble. GPS would be gone, communication satellites, fried, power grids would become massively unstable, and forget about flying or space travel. The radiation levels would be lethal.
But what about us? What about life itself? The danger there is even more terrifying.
We'd be looking at soaring cancer rates from cosmic radiation. The ozone layer, our protection from UV rays, would be damaged. And this is a big one. Phytoplankton in the oceans could collapse. These tiny organisms produce about half of the oxygen we all breathe. Not to mention, birds, turtles, all sorts of animals that use the magnetic field to find their way, they'd just be lost.
If you want to see the long-term consequences, just look next door to Mars. Earth, with its shield intact, is this beautiful, blue, living world. Mars, on the other hand, lost its magnetic field billions of years ago. And what is it today? A cold, barren, radiation-blasted desert with an atmosphere that's less than 1% as thick as ours. That is what's at stake. That's the difference a working geodynamo makes.
Okay. After all that doom and gloom, let's pull back from the edge of the apocalypse and get back to reality. Because it's time for some good news. Let's talk about how our planet's core is actually doing.
So here's the bottom line, the most important thing to remember from all of this. A geodynamo failure is not something we need to worry about. This is pure science fiction for us. The engine of our planet is still running hot and will continue to do so for billions of years to come. We're safe. And what's really wild is that our magnetic field isn't even static. It's constantly in flux. It gets weaker, it gets stronger, it even completely flips its poles every few 100,000 years. I mean, these are huge planetary events. And guess what? Life on Earth has been through it all before, time and time again, and we're still here.
And that really brings it all home, doesn't it? When we study these massive, powerful forces deep inside our own planet, it's not just about satisfying curiosity. It really highlights the incredible, delicate dance of systems that all have to work together perfectly to make this planet a home for us.
So the next time you glance at a compass, or just walk outside and feel the sun without being fried by radiation, take a second to think about that violent, churning engine thousands of miles beneath your feet that's making it all possible. It really makes you wonder, what other incredible, invisible forces are out there, quietly protecting us and shaping our world every single moment?